I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have
Hello and welcome back. This part we're going to start putting parts back on the radio, some of them, and then we'll take others out. We're going to start by remounting the newly stuffed electrolytics right here. And they go, I cleaned this bracket up so it looks a bit better. And they'll go right in here. But before we can put them in, we have to take the old one out. Well, the less old ones out. These were the old ones. Somebody put a couple of replacements in there at some point in the past. And I'm going to take these out, and then I have to rewire, according to the schematic, where the new old ones go. So I need to grab the schematic here. So we'll start by taking these ones out, which I will unsolder this guy. This one is an odd one to me. I'm not sure, the parts chassis I have doesn't show it. I haven't tried to look it up yet to see which of these trimmers it's going to. It's like this one right here, this trimmer. So I don't know what trimmer that is. I don't know whether they were having noise problems and put this cap in there. 8 microfarad, 450 volts. It's undoubtedly an electrolytic. I'll have to see if I can find it in the schematic, but it's not existent in that form, at least. It may be replacing another Bakelite capacitor, I don't know, but in that form, at least, it's not in the parts chassis, which looks to me to be all original. This one is not, but that's okay. That's what we're here for, to put it back the way it was as best we can. So I'll start by unsoldering these guys, get them out of the way. Whenever I run across a modified radio, I always try to make sure that they actually replace the parts correctly. This cap here, which is on the schematic, this first one right here, has its negative side attached to that point, which is the tie point right here for these voltage dropping resistors. So that's correct. And the positive side goes to pin 1 of the rectifier tube. So that's correct. So this one was replaced correctly. So I'm going to leave it right there for right now. I'm going to mount the replacement capacitors so I can pull one and put the other one in. Which shouldn't take but a second, he said. Whoever he is, he's a funny guy. Okay, I need to crimp those back down and hopefully they won't break. All right. Now these two lugs on here need to go in toward each other so they can be tied together. Now it should be fine. And then this one goes in the same way. The lug facing, the ground lug facing the center. Oh man, there. Now when you put these in, it's possible to push them all down. The cardboard should keep this from shorting to this. Keep in mind that the negative side, the shell of these two caps, is not actually touching chassis ground, and you don't want it to. So you may have to back them out just a hair, but probably not. That paper should provide plenty of insulation. I think that's just about right. And I can tighten the screw and we'll move on. There they are. Now if you look in there closely, let me move the camera. This is the trimmer for the low frequency trimmer for the police band, and the cap plate is coming up right here, right next to it, which is kind of scary. So that doesn't need to be that close. We can move that by just bending this over a bit, and we can solder to it without fear of creating a short, hopefully. Okay. So we can take this out. The positive lead needs to run from, or the lead needs to run from the center tap of the cap to pin 1 of the rectifier tube, which is right here, and just from there to there. Whoever did this, well, originally this wire, which runs over to the this wire right here runs into the field coil, but they moved it from a connection here to a connection on the tube. It's the same point from here to here and then on, so I'll just leave it there, and I'll just run a lead from here to our new cap. It should do it just fine. By the way, tubes, I ordered Tubes and More has a nice selection of cloth-covered wire. I ordered a bunch of it from them because I want this to look, you know, sort of like it did. So here's as close as I could get to, you know, kind of the generic brown that's used in here. I have generic green, generic yellow, generic red. But Tubes and More makes this wire. It's pretty decent, and if you need some, check them out. And there we have it, the new capacitor tied to pin 1 of the rectifier tube. I decided to restore this wire to where it was originally, just because. There's no good reason. I just decided to do that. Why not? Anyway, there it is. Connected back up as it should be. Now we'll move on to this guy. Okay, it's all in. The 2 new caps are down here. the wires have been run appropriately from the tie points down here to where they need to go. This green wire is larger in diameter than the original, but close enough. It kind of blends in. I suspect it's very high voltage wiring, it's highly insulated. But it'll do. So there it is. 2 new caps in, and now I've got to consider this guy. I looked through the schematic. There's no other electrolytic, particularly an 8 microfarad, which it says right there. I know it's upside down, but it says 8 microfarad, 450 volts DC, and it's tied to this trimmer, which is the second IF trimmer. So if you look at the schematic, here's the second IF, here's the trimmer right here, and I don't see a place for a capacitor anywhere except this one right here, which was already in circuit. So I'm beginning to wonder if somebody didn't accidentally, maybe the first attempt at replacing these 2 caps that failed was to put this one in. It's an oddball. It doesn't fit here. It's obviously tacked onto the case of this capacitor array here. I am at this point just going to take it out. I don't see any reason for it to be in the radio at all. At this point, we have this filter cap and this filter cap replaced. In this version of the circuit, these things don't exist, so I just X them out. Next, I want to tackle this 0.015 microfarad filter. It's a noise filter for the AC line coming in. So I will put a Y cap in there. Y caps go from one side of the primary to ground. X caps go across the 2 line cords, neutral and line. A Y cap goes from the neutral to ground. These guys will short open, and all that happens is you get less noise filtering. When you use an X cap and it's across a line like that, they'll short closed. Interestingly, I've always said they both short open. They don't. I've been saying it wrong for years now. The X cap shorts open, the Y cap shorts open, the X cap shorts closed, and the intent is to short this, blow a fuse in your house so as to protect the rest of the radio. And while it's working, it filters out noise. So that's the difference. This is in this box right here. This capacitor is number 49. It only has 1 capacitor in it, and that's at the end here. So what I'm going to do is unsolder the old power leads are right here. I'm going to unsolder those. They're using, as I said, this middle one just for a tie point. So I'll take the tie point off, and then we'll lift this out. And as you've seen from many other people who do Philcos, we'll do a short demonstration on how to remove the capacitor from the can and restuff it. I've desoldered the 2 leads. This lead and this lead over here go to the primary, across the primary of the power transformer. So the capacitor, the Bakelite capacitor, is free of encumbrances except for that thing. So all I have to do is take a 1/4 inch nut driver right here, and there it is. There is a star washer embedded in the bottom. If it's embedded, oh, it's not. I was going to say if it's embedded solidly enough, I'll leave it, but it's not. Okay, there's our Bakelite capacitor. It's not actually a Bakelite capacitor. It's a capacitor housing, a Bakelite housing. There is a capacitor in this housing. The ground wire comes out here and attaches here. The, what is it, 0.015 microfarad capacitor wire comes out here and is tied on here, and then the outside world ties onto these guys. The center one doesn't have a wire because it's not connected to anything inside this Bakelite case. It's just used as a tie point to move power on to other places. So I'll take this upstairs and clean this up a bit, and then we'll see about removing this waxy substance right here. I think Philco called it a hardened wax. A lot of people think of it as tar, but I don't think it is tar. But we want to get that out of there without breaking the Bakelite. So that's the goal.
How about a book on piano playing for beginners?
Oh, certainly, sir. Here's one right here entitled Cantatas for the Kiddies, or How to Make a Louse Out of Strauss.
Okay, wrap it up.
Oh, but McGee, that's for children. You don't want
I ain't proud. I got to start at the beginning, ain't I? I don't expect to be on a par with Fritz Kreisler overnight.
Chrysler is a violinist, sir.
Didn't he play the piano?
No, sir.
Oh, then I am on a par with Kreisler. That's encouraging.
You're also on a par with Gene Autry's horse. He can't play the piano either.
Here's your book, sir. $2.
Okay, Bud, here you are.
Thank you. And I sincerely hope, sir, that you get along nicely with your music. I myself am by way of being a composer, you know.
Oh, how interesting. What have you composed, sir?
I wrote an impressionistic little thing for string ensemble. It was a descriptive piece about a man waiting outside the maternity ward.
Ah.
Oh, that's a kind of a cute idea, but...
Yes.
What'd you call it?
Hubby Lobby. Well, good luck with the lesson, sir.
You know, Molly, I got a feeling this marks a turning point in my life.
You've had so many turning points, you'll soon be known as Whirling Fibber McGee.
Oh?
Well, hello there, daughter. Hello, Johnny. What you doing?
Well, McGee just decided to take piano lessons, Mr. Oldtimer.
That so? I come from a musical family myself, kid.
Oh.
Papa was a surgeon, and just to relax, he used to play tunes on his saw.
I'll bet his patients love that.
We never knew. Trees don't talk.
Oh, he was a tree surgeon, huh?
Yep. Spent 4 years as an intern in a lumber yard.
I had a cousin that was a tree surgeon, specialized in optical work on bird's eye maple.
Oh, McGee.
That's pretty good, Johnny. But that ain't the way I heard it. The way I heard it. You play any other instrument, Johnny?
Used to. When I was wooing Molly here, I used to play the mandolin on canoe rides, but she made me give it up.
What for, daughter?
Because I got tired of doing all the paddling, that's why.
Oh. That's pretty good, too, daughter. But that ain't the way I... by the way, you read music, Johnny?
I did once, and I can pick it up again pretty fast. Why, when I was a kid, I studied for a long, long time under the famous Professor Ware. Long Underwear McGee, I was known as.
That's pretty good, Johnny, but...
Long Underwear McGee, the mighty mucky muck of the metronome, making mugs, the mediocre musical mucks muddling through a mess of monotonous medleys, making millions marvel at the minor melodies made into magnificent masterpieces by the miraculous movements of my magic mitt, nipping many a maestro as I modulated from march militaire into minuets in G, and that's the story of Long Underwear McGee.
Now we want to consider the last capacitor that I think is critical to be replaced, and that's this guy right here. Coupling capacitor between the detector and the output tube. And again, the detector is, the signal is being placed on the plate of the detector, and the detector voltage can be quite high, and being passed through this coupling gap to the control grid of the output tube, and the control grid does not expect anything like the voltages that appear here. So if this capacitor shorts, this voltage gets applied to this grid and this tube burns up, potentially burning up your audio transformer, your output transformer as well. So we want to replace that one. It's an old one. It's undoubtedly a paper cap inside a Bakelite box, and it happens to be right here in this circuit. It's 2 capacitors in one can this time. We've got a 0.015, the coupling cap, and there's a noise bypass cap here of 0.00011 microfarads. We need to replace those. I can come pretty close to laying my hands on a 0.015. What do I have here? 102. And for this one, I'm just going to do a 0.001, not a 0.00011 microfarad cap. I think the 0.001 will be close enough. They're both in this housing, and so the trick is to look at this and determine which of these capacitors, and there is a lead coming out of each one of these connectors, so which of these capacitors is actually the 0.001, and which one is the 0.015 microfarad capacitor. So we start by looking around here, and we can see that the 0.001 right here goes to ground. So where's ground? Well, there's ground right here, and as we saw, and you can see it right here, in fact, the screw would provide chassis ground right here. They chose not to do that in this case for who knows what reason. Instead, they soldered it to this lug of the potentiometer, the volume potentiometer. So that seems very odd at first glance until you look at the volume potentiometer and you realize that one end of it does indeed go to ground. So just for convenience sake, this one is tied to ground, so this is our ground lug, and we know that this capacitor goes from ground to this point here. This point here is actually a common between the 2 capacitors we're going to replace. So that's the ground lug. The question is, which one of these 2 is the 0.015? Well, we can look at that by looking at what everything else is connected to. For example, on this lead of the Bakelite capacitor, it's going over here to, let me see if I can get some light in there somehow. There. It's going to this coupling. There are 2 resistors here that are coupled together, and then a wire is running off to somewhere. So we can look back here and say we're going to, from one end of this purple resistor to where it joins another purple resistor, and it just happens that there are 2 70,000 microfarad or 2 70,000 ohm, 70k ohm resistors right here and right here. Those are the purple colors that you can see probably. I hope you can see them here. So that's one end of the purple capacitor. So that's here. It still doesn't tell us where the other one goes, so we've got to find this point. Oh wait, we don't have to. We can find where we go to point the pin 4 of the output tube, the 42 tube. And the 42 tube just happens to be right here. And pin 4 of the 42 tube is 1, 2, 3, 4 right here. And it's this wire that comes up and connects to here. So at this point, we know that this is the 0.15 capacitor. That's this guy. The other one must be the 0.0001 microfarad capacitor. So that one's the 0.015, that's the 0.0001. And now we can desolder these, and with some success, with some luck, take this apart, replace those two. So, do I have a 0.015 microfarad capacitor? No, I don't. Do I have a 0.00011 microfarad capacitor? No, I don't. So we're going to have to make them up. What I do have is a 0.01 and a 0.0068 microfarad capacitor, each rated at 650 volts. If I hook these up in parallel, twist the leads together and solder them, I will end up with 0.0168 microfarads, and that's close enough in our coupling cap to 0.015, 0.0168. It's not going to make that much difference, and I can just use these that I have on hand. Likewise with the 0.00, what is it? How many zeros? 00011. I can take a couple of these guys. This is 68 picofarads, and this is 39. I put them in parallel, and that'll add up to 107 picofarads, or 0.000107 instead of 11. Which will be plenty close enough for that. And again, these are rated at 500. If you put capacitors in parallel, the capacitances add up. It's kind of the opposite of resistors. If you put these guys in parallel, the capacitance add up. The only thing you have to be aware of is the capacitor with the lowest working voltage rules. If I had a 68 picofarad capacitor here, for example, but it only had 10 working volts, then these two with its 500 volt and this one with its 10 would only have a working voltage of 10 volts. So in this case they're both 500, so the working voltage will be 500. And in this case, one is 630 and the other is also 630. So the working voltage of these guys will be 630. So I'll be putting a couple of caps in to replace the 0.015 and a couple here to replace the 0.00011 microfarad capacitor. Now let's get this out of here. Okay, let's check these out, see if they come close to what we need. (119 picofarads). That's about 120 picofarads. And that's about 0.00012, give or take. And we needed 0.00011. So pretty darn close on that guy. And where did that one go? This one. (16.49 nanofarads). Let's call it 16.5, between 17 and 15. So that's around 0.015 617 microfarads, and we need 0.015. So we are plenty close enough, I think, for these, for both the coupling cap and the bypass cap, bypassing high frequency noise to ground. So let's put them in the can. This is the 00011 replacement. I've put heat shrink on one lead because I don't want it to touch the other capacitor when it goes in here, or short the other capacitor. So that goes in there like that. A wrap around here. And a wrap around here. Oops. It's in there nicely. I think there'll even be room for these guys when they get ready. I think we're good. We're just touching the plastic body of the smaller capacitor there. So I think we're good. All right. Put this back in its place. Solder it in. That should do us. Okay, we have a stuffed coupling cap, restuffed coupling cap here. So that takes care of the coupling cap, that takes care of the cap, the safety cap. We've restuffed the filter caps, and without doing anything else now, I mean, there's every one of these needs to be restuffed and will be. I can't remember why I loosened that. So they will be restuffed. There's a lot of work to do left in here. This isn't done by any means. I have to go around and confirm all the resistors are within tolerance. I have to take this mica mold out. That's this guy, right? Can't tell. One of these two is a mica mold. Will have to come out. They've got to take the volume switch off and lube it and get it working again, and clean up the volume control. I'm sure the band switch needs cleaning. It's not broken like Larry's was, thank goodness. So I don't have to create a new part for it, but it does need cleaning so it works properly. The tone, that has to be restuffed. This guy, these two guys, and this one right here. So there's a lot of work left to do, but at this point I think we can apply power and see if our power supply is working correctly, because that still remains a bit of a concern, as whether the power transformer is up to snuff. We'll see. So in the next video we'll bring power up for the first time. See you then.